Starting the timer. Do I get a couple extra seconds here? Because you're still setting up? All right, there we go. So I'm going to move pretty quickly here, and I also want a gift here. You guys didn't see it, but the gift that Lorenzo gave me was that I have wanted to attend a European MUM since I started my company, but unfortunately that was 2020, and no MUM since then. So appreciate the gift there, Lorenzo. So today we're going to talk about doing a MikroTik CHR on Proxmox, and the agenda is going to be a quick intro. We'll get into the problem, talk about the solution that I came up with, and then walk through the example of the configurations that I did to accomplish the task. So first off, who am I? Been doing MikroTik since 2006. I created a company that managed Wi-Fi for MikroTiks back in 2015, and now I'm on my second centralization software for MikroTiks. We help MikroTik operators all over the world streamline their operations, get more done with our centralization and automation tools. If you want to learn more about that project, check out admiralplatform.com. Let's get to what the problem is. So with my software, one of the things we need to do is model a complex OSPF network so that we can automatically draw a representation of what the topology of the network is. So when we did this in our lab, you can see here I've got 7 nodes. Our software draws that lab okay, but I wanted to build a much more complex network. So as we released our software into the world, what we saw was that it does not do a good job and has many bugs for modeling the network. So I need to build a much larger lab, and currently I'm at 20 nodes. I need to get to 100 nodes, but where we're at today, I'm going to show you what that is and how it looks like for resources. So if we take a look here at this, this is really ugly, and I'm going to talk about, you can imagine that for a 7-node lab, I've got to have 7, I'm using HAP AC lights, they're 40 or 50 bucks. I got to have 7 power plugs, I got to have multiple network cables. It's a real pain in the butt to manage there. So when I looked at what I wanted to do, first off, I needed it to be a low-cost solution. I needed it to be easy to use. I wanted it to be very simple, and I really needed to avoid putting more MikroTiks in my lab. My lab is in my office. My wife and I share an office together, so really needed it not to take up my side of the room and really fill up the whole room with a bunch of gear and cables, and she hates all that mess. So first off, I decided, hey, let's try and do this MikroTik Proxmox CHR lab. I grabbed a garage sale PC that I had for 40 bucks. I took an SSD that I bought off of Amazon for less than 20 bucks, and I got 2 sticks of RAM and plugged this all together. If you got any questions on how that looks, you can check out admiralplatform.com. I'll do a blog post on this presentation next week so that you can get these diagrams and kind of get them in full detail, because there's going to be a lot of info on the slides that we're not going to have time to really dive into. So if you want to take a look at this later on, take a look there. So one of the things that I thought of was originally I'm going to use EVE-NG or GNS3, which are the real common emulators for doing any kind of network lab modeling. And as I started looking into it, this lab PC, this old garage sale device, it's only got 1 network interface card, and it got to where I started thinking there's going to be a lot of complexity in trying to create the emulation and the drivers on top of each other between the hypervisor and then Ubuntu and then EVE-NG or GNS3. So, I thought, hey, one of my heroes here, everything should be made as simple as possible, but not simpler. So I looked at these stacks and I thought, hey, can I take and just drop a MikroTik CHR right on top of Proxmox and then have the hardware underneath, instead of having those additional layers of Ubuntu and EVE-NG? And what I found is, yeah, absolutely you can. So then clean, now I have just one PC sitting on the desk instead of 20 MikroTiks. And as I mentioned, that's going to scale up to 100 MikroTiks here in the next week or two. And all of, again, the power cords, the power outlets that you need, all of the patch cables to go between them. Instead, we can virtualize the whole thing and just have one little machine. So let's jump into how I accomplished this task. And the trick, the magic here is just using VLANs on Proxmox. So in your GNS3 or EVE-NG emulation software, you'd build some virtual switches, you'd connect these together with the virtual links. On Proxmox, what we're going to do is really just use some numbers to tie these machines together, and we'll talk about that a little more in detail in a moment. What I'm not going to talk about in this presentation is any of the network engineering. If you need to learn subnetting and all that stuff, this is not the talk for that. And also, I'm not going to go into how to install Proxmox, nor am I going to talk about OS configuration, OSPF tuning. Even though that is what's in the lab here, I'm just going to assume that you can get that knowledge elsewhere. So what we're going to talk about today is just how do we get the CHR onto Proxmox, and then how do we tie those CHRs together. So there's some guides out there on how to install a CHR directly onto Proxmox. For ESX or Hyper-V, there are images that are readily available to install your CHR. And on Proxmox, it's a little more complex. So I'm going to walk through those steps just in case you've never done this before on a Proxmox machine. There's also a video out there that I did on this and a blog post so that you can check this out later. But so there's a handful of commands here. You have to download the image from MikroTik. You have to unzip that image, and then a QEMU image convert that's going to allow you to get it into a format that Proxmox can use. So real quickly, we'll walk through a couple of these configurations here. So you're going to create a new virtual machine. You're going to give it a name. Instead of using an image, you're just going to say, hey, do not use any media. Some of the stuff, we'll just click next. This one's important. You do have to change the disk from 0 to 1, and that's basically just going to allow you to say, hey, we're going to trick this environment into being able to use the image that we actually want it to use. So that's kind of like a placeholder disk location. So I selected here actually 2. I didn't show it on this screen, but I did 2 cores instead of 1 core. Because I'm modeling OSPF, I want to have a little bit more resources. But again, this is a $40 garage sale machine. If you wanted to throw some more hardware at this, you could assign as many cores as you need to model a more complex or more robust lab. But it only needs 1 CPU. It only needs 128 megs of RAM. It really only needs 64 megs of disk. And biggest thing here is do not click start after created. If you do, it'll be a challenge to fix that. It's actually easier to just delete the VM and start over and follow the guide the right way the next time. You'll spend a lot of time getting that back into the right shape. So I highly suggest be careful with this part. Just don't click next on that with start after created. Make sure it's not checked. So once we've built the VM, now you'll come into the network and add a Linux bridge. And this is the magic of what happens for the whole environment here. What I decided to do is that the VM bridge 0 that automatically comes with Proxmox is going to be my internet connection for my first CHR that gets me into the whole lab. And then all of the rest of the machines in the lab are going to be connected to VM bridge 1, where I'm going to do my VLAN tags. You'll notice there that you want the VM bridge 1 to be VLAN aware. You could make VM bridge 0 also VLAN aware if you'd like to, and that would unlock some more options. But we'll just stick to how I got this working in my lab. And then you'll notice that here, the big trick for getting this guy to load and boot is to use the VM ID, and there's a command you can run here. Like I mentioned, I'll have all these details on the blog post so that if you need to zoom in, if it's not readable here, you can check that out. But so we run a command that basically ties now the CHR disk image that Proxmox can actually use to this VM that we just created. Now, once that step is complete, you come in and you change some of the disk settings in the hardware. And again, steps here, we just go add this disk to the VM that we just did in the command line. Then we're going to detach and remove the disks that were already assigned to the Proxmox machine. So you saw there we detached it. It becomes an unused disk. We remove it. And then the final thing is you got to come in here and say, hey, I want to boot off of that disk that we just assigned to that. Otherwise, it tries to pixie boot or get its configuration, or not configuration, but bootloader off of the network. And so this will, prioritizing it, you want to drag and drop it up to the top of the list and enable it so that it can boot off the disk that we just assigned it to. All right, so now once that's done, you only have to do that one time if you're going to do what I suggest you do after this, which is to clone that VM so that you can do it again and again and again. The first time you have to build that way. If you wanted to, you could build the rest of them that way, but you can see that's a relatively many number of steps to go through. It's not hard. Once you've built a couple of them, it's very straightforward on how to get there, but it's much easier to just clone those VMs over and over and over again from here. So this is the lab that I wanted to build, and what you'll notice here is that I just went through in network engineering, I just assigned some VLANs to every single link. And so the way that this is going to work is that each link has its own VLAN, except for a couple of exceptions that I did for some interesting info, 2101, 2102, 2103, 2104. So 2104 is shared network. I'm emulating here a bridged or switched network between these four routers. And same thing I did over here on VLAN 2111 between 3 routers. So you can make this network emulate some complex capabilities that you might see in the real world, where you run into some gear that maybe can't do the best practice of having point-to-point networks. So this is just a zoom in of the configuration. So what I'm going to do is walk through how I configured CHRs 1, 2, and 3. And then all the rest of them I did behind the scenes. We're not going to run into how every single router is configured. Again, when I do my blog post, I'll dump configs of all of the routers, so that if you wanted to rebuild this lab in yours, you can do that with an easy copy and paste. So to start with, we go to that virtual machine 201. We add a network interface because by default it only has the VMbridge 0 interface that connects it to the internet, which is the Proxmox hypervisor's emulated NIC that is connected to the rest of my network. So the one physical interface is connected to that guy. So then I connect all the rest of the virtual machines to this VMbridge 1. And you'll see here that you assign a VLAN tag to each of those. So all you've got to do is follow your network engineered VLAN tag assignments and plug in the numbers here, and those virtual machines will use that as their virtual link. And so in this way, we can build a complex lab. So I put 2101 on CHR1. I'm putting all of these on CHR1. So 2101 is going to be on my second virtual NIC, and then 2102 is going to be on my third virtual NIC, and this points to CHR1 can now get to a path to CHR2 and CHR3. So once I was done, I have 3 network interfaces on my first virtual machine, and the first one goes to the internet and is on VMbridge 0 untagged. Then my next 2 are to CHR2 and CHR3, and they're tagged with the 2101, 2102. Finally, I was able to start the VM, and it boots up, does its thing. You can see you get the MikroTik login screen, and if I did an interface print, you can see there I've got 3 Ether interfaces. So real quick configuration. not going to go into any of the details here. I'm already down to 10 minutes. I want to make sure we've got time for questions. So this is the entire configuration on CHR1. I've prepared it to talk OSPF to its neighbors. And if you have any questions about the configuration, this should all be pretty straightforward. We stuck some IP addresses on those interfaces and created an OSPF network. This is all router OS 6. Also, I didn't want to get too complex with mixing in router OS 7. Certainly, you can do the same thing if you want to mix and match versions to prove that out in your lab too. So moving on to CHR2 and 3, this is where, like I mentioned, you're just going to want to clone each of your environments. And so what I ended up doing as I continued to move on was if I needed, and here I've got my image, if I needed a MikroTik with 2 interfaces, I ended up cloning CHR4 over and over again. If I needed one with multiple interfaces, I would clone one of the ones with multiple interfaces. So it also saves you time as you're moving on in your modeling. But so here we go for CHR2. We just clone and then change those VLAN tags. So you're going to head into the hardware network, double-click on the network interface that you want to adjust, and plug in the VLAN tag that you had from your drawing. That's all it takes. So this is my subnetting plan. Again, this will be posted on the blog post. So then CHR2 connects to CHR1, CHR2 connects to CHR4, CHR2 connects to, CHR2 connects to 5, 11, and 6. And so final configuration. I did come up with one more thing I wanted to do. I ended up turning on Roman on the whole network. So this is highly recommended if you're not using Roman. This helps out so that you can hit that first MikroTik that is connected to the rest of your network, and if you roam onto him, you'll have access to all the rest of your lab. So just wanted to show here some validation. I can ping my neighbor. You can see here I'm on CHR2, and he can ping CHR1, and we're getting OSPF routes over the network. So pretty simple and straightforward. Taking a look at CHR3, I just wanted to, for completeness, include some of this documentation. So CHR3 points to CHR1, also to CHR6. Again, we're just filling in the VLAN tags. The nice thing about Proxmox emulation here is that it's automatically assigning new MAC addresses. So as long as I'm not putting MAC addresses in the MikroTik's configuration, cloning is just going to work. You don't really have to do any of the things you'd have to do on some other labs to do MAC tracking. CHR3 connects to 8. And then on CHR3, I also had an additional interface. So this shows how if you need to add more interfaces, you can just go add network device. Again, tag it with a VLAN tag and hit add, and you can have as many interfaces as you want. So you can put 20 interfaces if you need them. So again, here's our configuration for completeness. And moving on, we're learning OSPF routes, and we can ping our neighbors. So at that point, it's a whole bunch of cloning virtual machines, updating IP addresses, changing the router ID on OSPF, updating the system identity, and one of the things I did run into is that if the interface names, because of the cloning, get kind of off, you want to go in there and say, hey, so for example, for me, I got some Ether 5 and Ether 7, and I wanted them always to be 1, 2, 3, 4. So if it goes 1, 2, 7, delete Ether 7 and then re-add it, and it'll come in as Ether 3. So there's a couple of things I learned as I was moving through this, and one of them was that, hey, interestingly, you can do the VLAN tagging on Proxmox, or you can do the VLAN tagging on MikroTik. So on your CHR, if you do not tag it on Proxmox, just leave the VLAN as a trunk port with a blank VLAN tag. what you can do is on your CHR, you can say, hey, interface VLAN stacked on top of Ether1, for example. You can see what I've done here with 2109. And then assign the IP address and the OSPF to that VLAN interface, and that also works. So even more complexity available if you want to go down that path. What was I trying to show here? Oh, so the other scenario that I talked about, 2111 is the VLAN between 3 different routers. And so you can see here we have 2 OSPF neighbors on that VLAN 2111. And so in that case, what we're able to do is say, again, on a virtualized bridging or switching infrastructure where we have a broadcast network, that's also able to be emulated here. So here you go, I got 21 MikroTiks and 1 power cord, 1 network cord. And what I think is pretty incredible is that this is, again, on a $40, I spent less than $100 on this lab, and I was able to, with 10 or 11% CPU, it's running OSPF. This has got 24 virtual links, 21 virtual routers, and that's pretty low CPU, in my opinion, for some older hardware. Obviously, I'm going to push this up to 100 units and see what the CPU load is, introduce some failures on the network and see what the CPU load is. But you can see here, with you can get some pretty robust functionality out of some pretty low-cost hardware. So originally, my goal was, hey, can I build a more complex lab so that my software can then take advantage of that lab and draw a automated network. And so mission success, after I was able to emulate some larger customer networks, I was able to get my software to detect that. And so that was the use case that I needed to build a complex lab for. That's all I've got. Questions? So failover high availability to Proxmox as I'm trying to, let's flesh out the question. I see. So you're saying so I have not personally tried that yet, so I believe that should behave pretty well, but yeah, I have not. So abstract it from the routing layer and let the hypervisor take care of it.
Hey Mark, how much do you think this solution can scale up?
So the question, how well will the solution scale up? Like I mentioned, that's one of the things I'll have to test is that right now CPU load's at 10%, but I also haven't introduced any link failures and redirection of traffic. Obviously, there's a super simple config on there. You saw it's, 15 lines. If we added firewall rules and some additional pieces there, I think my lab's going to not hold up very well. But again, that was under $100. If you wanted to spend $500, you could certainly get some old 1U, drop that into your data center, and say, hey, I'd throw a couple $100 to $1,000 of hardware at it, and you could really build an extremely monster lab with some very complex rules, including doing QoS and et cetera, and really model the whole thing. But in my case, my goal is to get to 100 MikroTiks and just have those on that real cheap, under $100 instance.
Anyone else?
Probably got time for one more if anybody's got any questions.
Yeah.
Hi. Is there any consideration using Proxmox rather than other virtualization platform like VirtualBox, VMware, or anything else? Yeah, I mean, why the consideration using Proxmox?
So was the question for oxidation and fail-to-ban?
Yeah, I mean, there is some other platform to do the virtualization. I mean, not only the Proxmox, like let's say VMware, VirtualBox, or anything else. I mean, is there any concern why you using Proxmox rather than any other
So you're saying compared to the other hypervisors?
Yeah, yeah.
Yeah, so obviously I focused on Proxmox because historically many of my customers have been wireless ISPs, and they've really adopted Proxmox, so it made sense to kind of go that direction. In addition, obviously it's free. If you haven't seen the news, ESXi is kind of going the way of the dodo, so we kind of wanted to have something that's easily accessible for everyone, regardless of your level of resources. And so it should work on any platform, though. So there should be no reason that you couldn't do this on ESX, Hyper-V, any of the other hypervisors that are out there.
Okay, thank you.
Anyone else?
Thank you, guys.